Right, so I started to work on a entity component system. Um, while I was coding, I was thinking things through, so it was difficult to talk about what I was doing as well because I started refactoring and changing things as I went along. So I began here with rendering out a load of sprites, and then started working backwards from that data, figuring out what I needed to render many sprites and how they could become entities or components that could be reused. So I just started thinking of what components I'm going to need, like a renderable component which has information that I need for rendering, dynamic component has like positional and physical information, and like a logic component maybe to store information about updating these objects. When I started doing that, then I realized I needed some maths library. So I'm just porting over my old maths library here. It's just a scalar math library with like vector 2, 3, 4 matrices and quaternions. Just using it because I've written it before and I can't be bothered really to writing another maths library. In future I'll probably optimize some of the maths and I'll do some maybe SIMD stuff with collision tests and stuff like that. The maths library's going into the utility toolkit library, so that can move around across projects. I just did a bit of renaming because I quite like having short type names, so I'm changing vector 3f to just vec3f and vector 2f to vec2f and so on. Also, this is some old code and there's a crazy if statement in the vector divide operator to assert on a divide by 0. Just using the Visual Assist refactor feature to batch rename all these types, which was useful. And there's also some functions in this maths library that I wanted to get rid of, like all these helper functions to convert matrix types to the fixed function OpenGL matrix types. I'm not going to be using OpenGL at the moment, and even if I do, I wouldn't be using any of the fixed function pipeline, so just getting rid of stuff like that. I also had a load of like primitive types and collision detection routines for things like cubes, spheres, oriented bounding boxes, ellipsoids, collisions with polygons and stuff like that. Some of it was using STL vectors and things like that, which I'm not too keen on using now, so I just ended up commenting them out, or like if-defing them out for now, and I'll refactor them as and when I need them if I want to use them or write them again. So finally ported that math stuff, load of renaming and refactoring, and then I started filling out these structs with data. So I already knew roughly what data the player needed, and just these are sort of rough ideas of components just to build the whole system around. Things probably going to change quite a lot, but I sort of need some data in the first place to make some decisions, design decisions about. But I don't want to have too much and think too far ahead, because I want to kind of have quite a bespoke system that's going to be fast for this particular game. So what I'm essentially doing is splitting up data that I need to update and render the game, and trying to keep separate little systems that do very specific tasks. So to draw and update the sprites, you need to render them, you need to update their constant buffer and update them. Those systems can exist in complete isolation from one another, aside from some data that they would have to share, but the idea is to keep tightly packed arrays of data for each subsystem close together in memory. So when you update the C buffers or update the dynamic components, you bring in all of the data into the cache that you need, and you're not bringing in any waste, which you would see potentially if you made a character object class which had C buffer information, vertex buffer information, dynamic component information. When you came to update the dynamic component, you would pull into the cache data that you didn't need when you were updating the dynamic component. So keeping these separate little systems means you can organize your data to keep the specific things you need for that task. And also it means the systems can sort of operate independently, and you can optimize them more easily than if they were sort of tangled together.